because period 4 always gets it. They always get recorded. Okay. So, I want to just go through a couple of these and talk about them, and then we're going to go on to the next pages. So, this is just like what we did for homework. I've got NE is congruent to OS. So right now, here's what's already marked congruent, these sides here. NE, I guess I'll do 4, and OS. I want to prove that, okay? That's what I want to prove. So I'm putting the lines there so that we can like anticipate it and see it. So I'm gonna go through the key steps. The whole triangle, RNX is the whole thing, side, side, side. You see that? Side, side, side. So I'm gonna put next to A, side, side, side. Now, if the whole triangle outside is congruent, every angle, every side, so I could go through and be like, oh, this one, this and this. Also these, N and O. So now in X and Y, well, the reason that X and Y are congruent is because of CPCTC. It's a corresponding part, it's the angle. The whole triangle was congruent. So that's going to be CPCTC. Next, NEX. Oh, well, guys, look. NEX. I know that this side, I know that this angle, right? And let's see. Side, angle, side. Can I do that? Side, angle, side. Okay, so that's going to be C. And then, because I know this triangle is congruent, I just did it. C, SAS. This is a corresponding part of congruent triangles. Okay.
Miss Grant?
Yeah.
Anna's in the waiting room. Can you let her in, please?
Thank you. I mean, it showed up in the lower right corner, but I wasn't paying attention to that. Okay, same type of thing here. Right angles, maybe think, hypotenuse leg, maybe. Just think because it's a right triangle, you know? It could be. We don't know. Number 2, I want to prove BE, this little perpendicular, and DF. So triangle ABC. Side, this one, side. ABC is this top triangle. Forget that this line is here. This reflexive property line that's shared side, 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 right? Then that means that angle 1 and angle 2 are angles that are involved in those. See this one and this one? You'd think, oh, maybe they're alternate interior. No, it's just that the triangles are flipped upside down. Angle 1 and angle 2 is CPCTC. ABE. Now, okay, you guys, if I know the whole triangle is congruent, ABE, then guess what? Every single piece inside, every angle, every side, so obviously, oh, but how did I know? Angle, right angle. Angle 1 and 2 are my first angle. Right angle, I see somebody, and side, right here. Angle, side. How do I? Angle, side. And then CPCTC. So these triangles are shared. Many of them overlap, and there's like, look at how many triangles are embedded on number 2. It's a parallelogram, but there's 1, 2, 3, 4, 5, 6 triangles that I see. 1, 2, 3, 4, 5, 6 triangles within, right? Okay, can you guys come on? I don't know why I'm telling you, you're here. These people coming in 20 minutes late, 15 minutes late, that's not okay. Okay, I am done with this page. What I want to do is I want to scroll down and I want to do some of these proofs that you see following. So let me do that. Right here. I know it says work with a partner to complete these proofs. I actually think that I just want to work with you because everything's blank. There's no clues at all. So we need to, well, I'd love to have some help too. If you want to talk, that'd be great. Okay, mark up what we know. MST. That is, what that means is that MST is a given line. Obviously you can tell though that it's going to be a reflexive property maybe somehow because it's shared. I have to put, as you can tell you guys, if given is there on number 1, all of the given must be written on line 1. So MST exists. They're just saying it's there. It's a line. Okay, which obviously we knew, but that's fine. They can say whatever they want to say in the proof. MA is congruent MH. All right, so that's good. AS is congruent to HS. All right. Well, I was told, like, if you look at this, where's my blue? If you look at this, isn't it kind of look like right now we're focusing right here? Just based on what I've been told. So I personally, well, I have an idea. Does someone want to share what they think might come next? Because the blue triangles are what we've been focusing on. What else? What could I write? Any thoughts? Oh yeah, sorry.
Can you say MS is reflexive?
I can say MS is reflexive because then I can talk about these 2 blue triangles. Because then reflexive property now the top blue and the bottom blue are congruent. And so I'm going to say like, you can go in any order, guys. MAS. Triangle MAS is congruent to M. If I go MAS, then I need to go MHS. See how I had to order it properly? By what? Someone at home. What's it congruent by?
SSS.
Thank you. Okay. Let's take a second now, because that was like obvious because a lot of the given had to do with those 2 triangles. Let's kind of look at what our end game is going to be, because is there a step 8? Because our end game has to be MT bisects. So I can't even write it down at the end because I know it has to be my last step. MT bisects ATH. Is it angle? ATH. That's way over here, guys. that this line cuts the angle in half. Okay, so we're talking about over there. Let me walk you through what the next steps are so that you know. If I start talking, and I can say a lot about these two triangles, if I want to say that MT bisects, then that means that I want to focus on the top triangle and the bottom triangle. Because I want to get to like here. I want to talk about these two angles here, that they're bisected. So I better start widening my triangular look, my look of it, because I don't care about just these two blue anymore. Now I need to actually start thinking about the whole triangle on top versus the whole triangle on bottom. So if I want to focus, I already know that this is congruent to this, right? Because it was given. This is kind of like when we did on Friday. In these blue triangles, the only part of these blue triangles that's also part of the black is going to be these angles right here. So I've got to talk about that angle. I have to talk about that angle because it's a part of the small blue and the big that we've got here. So I'm going to say this angle by CPCTC, right? Blue angle AMS is congruent to angle. If I go AMS, I better go HMS. Oh. That's CPCTC. So now I've got this angle, guys. I just did it. I'm really getting close because I need to talk about these angles. I already know a side. I already know in this angle that was included. I'm going to now talk about this shared. Right there, guys. It's reflexive, MT. Reflexive property. Because now that I know that the top triangle is congruent to the bottom triangle, I can start talking about these angles here afterwards. So I'm going to say that the top triangle, triangle MAT, is now congruent to the bottom black triangle, MHT. Side, angle, side. See side, angle, side? I want to recap on what I've done so far. Because I really remember sitting in geometry when I was in high school and thinking like, how did the teacher know to write that step next? I would never have known to put that next. How did they get from, like, it's all blank. What am I supposed to do? So let me recap what I did. First thing that I did is I started talking about the top blue and the bottom blue, okay? So I had to first focus on what I was given. And then I was able to do side, 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 right? Reflexive, side, side, side. That's how this all happened. Then what I did is I noticed that my end game is to talk about these two angles right here. So I got to start incorporating more than just the blue triangles, which means I had to start incorporating like new triangles. Obviously, if I'm talking about these two angles, top triangle, bottom triangle. So I drew them over here separately so we could focus on it. I was able to say these two angles in blue, since the triangles are congruent, I know that every part is congruent. So that's going to be a CPCTC. Luckily, this angle right here at the corner on the left, this angle on the corner on the left is also part of the big top and the bottom. So that made me tie in, and now I'm done with little blue, and I'm only focusing on the top and the bottom. So I had to prove those triangles congruent. Because if I prove this top, and I'll even like top triangle here, congruent to this bottom triangle here, then I'm gonna get to what I want, which is these angles. So it's a slow process, and it's like, okay, well, what do I need? What's my end game? I had to write that at the end, so I knew it was what I was reaching towards, and then I slowly get there. Now that the top triangle is congruent to the bottom triangle, let's talk about the angle. It is ATH. So the top angle by CPCTC right here. This angle and this angle are now congruent by CPCTC. Angle ATS. And I actually want to call it ATM. Angle ATM, because we're done with S now. We're done with the small blue triangle. ATM is congruent to HTM. And that's CPCTC. We're done. This is it. Let me explain to you the reason for the next one. And I know that this is an extremely hard proof. I know. I'm very aware, but I have to challenge you. You can't make everything easy. I mean, this is Troy. Come on now. Let's challenge ourselves, right? Okay. If I know that the angles are congruent, and I'm supposed to prove that a line bisects the angle. If the angles are congruent, doesn't it make sense that they're equal? I said they're congruent. And also, doesn't it mean that if they're the same size, then obviously something cuts them in half? It's like, I know that this is the same as this. So yeah, they're equal. They were cut in half by something. So here's the reason I'm going to say, here's the verbiage, here's the words. It's a lot of words, ready? And it's basically the definition of angle bisector. So I'm going to write the words though, but it really is an angle bisector definition. An angle bisector, right, really small, there's a lot of words, is a ray that forms two congruent. An angle bisector is a ray that forms two congruent angles. An angle bisector is a ray that forms two congruent angles. Okay, and with that, we are done. So, all right, that was a lot. I started out with two separate triangles, and then I focused on the bigger triangles that were involved, and I got this 8-step proof. So I will gladly do an 8-step proof with you, but I'm not going to give you a blank 8-step proof on the test, especially when we're doing online learning. I could probably do it when we're sitting in class, maybe 5 steps, but an 8-step blank, woo, crazy. So let me actually, I can stop recording because we're done with this.